Alright, hi everyone. In our previous video, we discussed about the time and space complexity of quicksort. And now let's quickly take a look at the time and space complexity of merge sort. Now before jumping on directly to the time and space complexity, let's quickly do a recap on how merge sort works. Now if you remember the definition, merge sort works by dividing the given array into smaller arrays until we get multiple arrays of 0 or 1 element. And once the array is divided into single element arrays, then we sort and merge them one by one. Let's take a quick look at an example. Let's say this is our given data. Now to sort this given data with merge sort, we have to divide it into multiple arrays. As you can see, we have divided this given data into two arrays that has 3 elements each, and we have to do it recursively, and in next step it will give us 4 arrays. As you can see, the first array has 2 elements, second array has 1, third array has again 2 elements, and the fourth one has single. And in the next step of dividing arrays into multiple arrays, it gives us 6 different arrays with single element. So it took total 3 decompositions to get to the point where we will have arrays of single elements. And then as per the definition, we need to sort and merge them one by one. So we will compare the first 2 arrays, and you can see after sorting and merging, we get an array of 2 elements, 1 and 9. And also here in this part you can see we have sort and merged these 2 arrays, that gives us an array of 2 elements, 0 and 2. Further moving on to the next step, we sort and merged these 2 arrays, that gives us an array of 3 elements. Same we did with this part also, that gives us again an array of 3 elements. And in the final step, we will sort and merge these 2 arrays, which means now you have to compare 1 with 0, which gives us 0 as the smallest element, and then comparing 1 with 2 gives us 1 as the smallest element. Then we have to compare 5 with 2 and so on. And after completing all the comparisons, this is our final output, and the given array is now sorted using merge sort. I hope this one is clear, but if you still need a detailed explanation of this process, you can check out my merge sort video. I will attach the link in description. Now coming on to the time and space complexity. So for the best case scenario, merge sort will have the time complexity of O of n log n, and also for average and worst cases it will be same. Now let's see and try to understand why it is n log n. As we just saw how we divided this given array into multiple arrays. We did 3 decompositions here, right? I mean 3 partitions. Like in first decomposition, it gave us 2 arrays. In second decomposition, it gave us 4 arrays. And in the third and last decomposition, it gave me 6 arrays. So for 6 elements, we did 3 decompositions, which means we have to done log n number of decompositions for n number of elements. And that's how we got log n here. And now when it comes to sort and merge, if you remember, we have to do n number of comparisons here, and from here we got our n. So we can say we have to do n number of comparisons for log n number of decompositions, which makes the time complexity O of n log n. And for space complexity, if you can see, eventually we will end up creating n number of arrays. So you can say we will need n number of arrays for n number of elements, and that's why the space complexity is O of n. Alright, that's all for the time and space complexity of merge sort. If you have any questions, let me know in the comments. Also, I think we have done enough searching and sorting algorithms. From next video, we will be covering some of these topics like linked list, stacks and queues, binary search trees, graphs, etc. So stay tuned for that, and thanks for watching.